Now we'll see the working of squid one by one. Before that, just we'll again see the schematic diagram of squid. So first point in working, a current DC supercurrent is applied to the squid. Here the word is supercurrent. The supercurrent is coming from arm C. Why here we are saying supercurrent? Because in superconductor, according to Wechsler's theory, instead of single electron, there is a Cooper pair, and that Cooper pair is formed by electron lattice electron sharing. So instead of single electron, there is pair of two electrons, and mostly that pair is known as Cooper pair. I am again repeating, it is Cooper pair. So current passing through superconductor is, we are saying it is super current. So I am repeating this point again. A constant DC supercurrent is applied to the squid. This current is known as bias current, which enter into the squid through arm C. Next, this current is divided into two parts, the path A and path B, and then it is emerging at the end, it is emerging to point D. See again this point, this current is divided along the path A and path B, and again merge into one and leave through arm D. Next point, I1 and I2 are the currents tunneling through the Josephson junction. See here again, from path A, whatever the current passing through junction P, and after that junction we are getting current. That current we are considering I1, and current passing through path B, and when it is crossed junction Q, that time whatever the current is coming from junction Q, that current we are saying as current I2. And again at the point D, these both current I1 and I2, they are unite and emerging through point D. Now in this squid, if there is no magnetic field applied, means first point, in absence of magnetic field, means there is no any specimen to check, that time what will be happen? That time, that is in absence of magnetic field, phase difference across P and across Q is 0. So there is no phase difference at both junctions. Second, of magnetic field. In the presence of magnetic field means when you are going to test any object, suppose we are going to check the brain, and we know human brain having some small magnetic field, that time what will be it change. So we are saying the presence of magnetic field. When magnetic field is applied, it changes the quantum mechanical phase difference. So when there is magnetic field applied, it changes the quantum mechanical phase difference across both junctions. So each junction, the mechanical phase difference will be changed. This phase difference between reuniting current, so that reuniting current we are getting at point D, that phase difference will be delta 0, is directly proportional to magnetic flux through the ring. This delta 0 is directly proportional to magnetic flux through the ring. So that across that ring, whatever the magnetic flux, depend on that we are getting these delta 0. The voltage across junction oscillate with the change in phase. So we are getting voltage across the Josephson junction oscillate with the change in phase at two junctions. This voltage depends upon the change in the magnetic flux. So as magnetic flux changes, the voltage will be changes as it is depend on that magnetic flux. Thus, by noting down the voltage across the junction, the change in flux and corresponding magnetic field can be measured. This is the working of switch.